Hi friends, so in this video we'll be looking at how to approach the problem 343 integer break. Now let us just review the problem statement. Given an integer n, break it into the sum of k positive integers where k is greater than or equals to 2 and maximize the product of those integers. Okay, so here the essentially what I can get from the idea is that we need to divide, given an integer we need to divide it into its possible sums and then get the maximum value of that. So let's have a look at an example. Given n equals to 2, output is 1 because there's only one way by which we can break 2, which is 1 plus 1, and the product is 1 into 1 equals 1. Now for 36, the saying we can break 10 into 3 plus 3 plus 4, and the product of these numbers is 3 into 3 into 4, which is 36. Okay, the constraints are n is less than or equals to 58. Okay, so here we have to somehow look at the most optimal way of dividing an integer, right, into components such that their sum is that number and we get the maximum product when we multiply those. So let us have a look at some of the examples. So let us suppose we have given n as 10, right? Now we can see that 10 we can divide it as 10 equals 1 plus 9, 10 equals 2 plus 8, 10 equals 3 plus 7, and so forth and so forth, and we can keep on doing this, and the last result would be 10 equals 1 plus 1 plus 1 plus so on. Now this is very bad, we know this, because the product will just be 1, right? And somehow we need to but from all these possible divisions, we need to figure out the best combination, which apparently is this 3 into 3 into 4, which is 36, but we need to somehow figure this out, right? So initially, now the most difficult part of this whole problem would be to have this division. Like, how can we divide them, right? How should we proceed? What should be the division? So let us make our life easier and instead focus on dividing the given number into just two sums. Basically what I'm trying to say is, if we've been given an n such as a 10 here, then what we try to do is 10 or any number, we try to divide it into two sums, that is, it's possible two sums. So for example, let's suppose if we were to be given a number like, for example, 6, then instead of thinking about how 6 can be written as a 2 plus 2 plus 2 or 3 plus 2 plus 1 or 1 plus 1 plus 1, something like that, we divide 6 into two numbers such that the sum is 6. So basically this could be one division, the other could be this, and the other could be this, right? I'm not mentioning the other one because they will just repeat, right? So I can write it as 4 into 2, which is same as this, or I can write it as 5 into 1, which is same as this. So basically these cases are more than enough. And now what I propose is, once we have decided to divide them into two numbers, then we just need to focus on these divisions, right? That is what I'm trying to say. Once you have divided, you choose to divide them, either you can further break it, that is, either you can further break 4 into 1 plus 1 into 1 plus 1 plus 1 plus 1, or 2 plus 2 or 3 plus 1, or you can take it 4 as a whole. Okay, or you can take it 4 as a whole. So basically something like either you can take it 4 or you can divide it into, let's say for example, 2 plus 2. And for all these divisions, do the same on all such divisions, this, and this. So algorithmically what it does is returns the maximum product of dividing n into its components. Let me just call it components, right? Components. So let me have int answer equals 0. Let me begin with this idea that I just mentioned. So answer will be max of answer comma max of I comma f of I into max of n minus I comma f of n minus I. So see, this is the same idea here. So for example, if I had 6, right, then I divide it into 2 and 4, and then I say either you can take 2 as it is, or you can take its product, whichever is greater, and similarly you can do the same for the right one, which is here I'm either taking that number itself or I'm taking that function of the number, whatever is greater, and then I say return answer, right? And let me just say return f of n. Now of course there needs to be some base cases. So for example, if n equals 0, then I have to return 0, though it won't be ever be encountered, but just to be safe. And we can even do this for 2, because we know that it can only be divided into those values. Now let me try to run this code. Okay, and let me try to sum like this. Let's see what happens. So we get a TLE, which is kind of what we can expect. This is because we are doing a massive stupidity. We are computing values again and again. Again, let me show you why. So let us suppose we try to divide 10 as 3 plus 5 plus 2, right? And so what we'll end up doing is something like max of 3 comma f of 3 for specifically this division into max of 5 comma f of 5 into max of 2 comma f of 2. Now if you really think about it, this is just for this division. Let us suppose we had another division like 5 plus 4 plus 1. Here you will notice we'll again calculate f of 5, which if you have been learning DP, you would have realized this is repeating. This is a sort of a recurrence, right? So basically this validates two of the most important conditions for DP problems. You can somehow store it, cache it, memorize it, and there's a recursive implementation. There's a recursive idea to this problem, which is explained here, right? The recursive idea of solving the left sub problem and the right sum problem, and then choosing the better results. So let us try to do that as well. So there are a lot of ways of caching the results. You can create a map, you can create an array. Since the value of n is very less, I'll just create an array for this problem and I'll name it DP, and I'll make it size 60. Okay, now I'll just initialize some of the values here itself. So I'll do dp of 0 equals 0, dp of 1 equals 1, dp of 2 equals 1 as well. Okay, and I'll create a function like this. So let me just make some few changes here. So first of all, the few change will be if n equals 0, return 0, because n will be 0 only if the case is n equals 1, right? Else dp of n is not equal to 0, then you return dp of n. Else what you do is you do this, and you say return dp of n equals answer. So basically this is assignment and then return. Okay, so I think this does make sense, and just to make sure that the values are 0, I'll use memset to fill the values. dp. Let me try this. Let me try to submit it. Voila, there, we get it. So I hope this does make sense. And here essentially the idea is to recognize that this has this repeating structure to it, and how we can break it into the left half and the right half sort of thing. I hope you liked it. Thanks for watching.